normally what we do is for our first session, we always look at a list of attendees who have more than 50% attendance, right?
Nice.
So we give them a certificate of attendance for those attendees. And when it comes to the second session, third session, we increase the constraint increases, right? So now Kubernetes, we expect people to attend 70%, and then the third one is 80%, and then eventually we will have some projects and things like that, right? So I was just telling Nahendra about it. Wanted you to know. We will provide a cloud fundamentals certificate of attendance to those who have attended this course. Thanks to you, Krishna, for that. So with that, further I'll hand over the session to you. You can kind of start it. I know that you have 2 sessions, and I also know that you have lots to cover. And I'm always interested to attend your session and so many good topics.
Thank you, sir. Thank you, sir.
Take time and leave it to you.
Yep. So, yeah, I think, you know what, this is the 14th week, so which is really good. I think thanks for everybody attending in, things like that. And I got to tell you, this is a very unique basic introduction, right? So if you see, we have covered, so from the first session with the basics of cloud computing, and then we went into storage, DNS, load balancers, application gateway. We had a deep dive on Kubernetes, a little bit deep dive. And then now we're moving into much more deeper dive following next month, right? So we covered a data, and then we touched based on marketplace, IoT. We had a very good conversation on IoT, and then Databricks, which is the big data platform we spoke about, and also we are other extensions of the data estates. In the last week, we briefly scratched the surface of AI and ML, machine learning model. Then again, we're going to have a very good focused section on this. So this week is pretty much on called the serverless computing. So I'll merge the 15 and 16 because those are basically the same. I'll compress them into a single flow so that it looks like a single session, so that the following week we can talk on the Kubernetes and things like that. So I'll redo my decks a little bit. So next week would be my last session from the series. So this series has been focused on ideation, giving you basics. You can always come back to these sessions to refer back to the basics. So this week it's another interesting topic as we embark into. It's called the serverless. We're also going to talk about functions, which is a type of serverless, and also we're going to talk about events, which is also helps you. Events are basically a new way of reacting to changes in the state, as I call, and then triggering an activity and things like that. So yeah, so this is one of the last conceptual thing. The next week, and we're going to compress DevOps plus a little bit of security and things like that. So with that in mind, I'll jump into at the very I would call these slides I call them as a level 100 slides. So what we mean by level 100 is you enough information for you to get a basic understanding of this. I don't expect people to dig deeper into this because it's a topic on its own, and sometimes it takes time to grasp the ideas. So let's go into serverless first, and then we'll talk about functions, logic apps, and then we finish with event grids. So hopefully I will be able to cover all the contents. Usually I talk a lot in between, so by the time we finish it, we miss one or two. This week I'll try and keep my schedule on track. So,
hey, Krishna, sorry, I was thinking that you were going to continue the AI for this week. No, next week you're planning for that, is it?
Yeah. So sorry, I think so. Okay, my apologies. I will okay. So I'll cover the AI next week if I totally just skip my mind. I'll focus on serverless and then come back on the AI, and then we split the next week into 3 chunks so that we focus on the AI and then look at the DevOps and security. Thanks for the reminder. So I was I didn't realize that. Sorry about that.
Okay, thank you.
So if you think about your the cloud development, there are multiple stages of that. If you see more and more companies are looking at moving away from the traditional concepts of building a server, keeping the servers running, updating the servers, or keeping a more deeper dive. They want to look at a couple of new things. Where what they want to do is they don't want to have any servers of any sort. They just want a service to be provided by a vendor of choice, and then focus on the end goal of getting things done. So we start with on-premises, which is your physical infrastructure that is hosted on your premises. Nothing different. We call you have your service, you have your software, you manage it, you bake it, you basically babysit the entire thing. Next came the iteration where infrastructure as a service came in place, where if cloud vendor like Microsoft or AWS or GCP, say Google, would come and provide them a virtual environment, which also removes you from the challenges having a hypervisor, don't need to manage it. You host your workloads and you're good to go. So it has got some challenges. Still need to maintain your operating system, still need to maintain your servers a little bit, and also other things are also impacting. So next came the next iteration. You know what, customer, don't worry about it. I'll give you a managed platform, which means you worry about only three things for you. You worry about your application layer, and you worry about your data layer. Rest of the things we will take care. You don't have to worry about patching your servers, because I know based on my telemetry, I know when to patch. I'll also give you high availability and disaster recovery by moving your code into a data store, which is basically extremely redundant, and your application code is separate. So you can scale out individually application code separately, and your data stores separately. So you have a massively successful system, no problems at all. So that was the platform as a service iteration. Even then, there are certain things that you as a customer have to do. You have to plan when to scale out, when to scale down. You also need to worry about things like redundancy and things like that. So this is not a very optimal path, right? Because you still have certain things to manage, and and this is where it comes to the next stage, where what, serverless comes into play. With serverless, pretty much you don't have to worry about anything. You just have to only one thing to think about, is building a piece of code. And then the piece of code, once you deploy into a serverless platform, what happens is automatically the platform would able to react and manage events on your behalf. For example, you let's say building a website. In the website, you're doing some sort of a processing of some sort. Okay, you hosting let's say a video sharing site, something like let's popular video sharing sites, short video sharing sites. So what you do is you have a service, and the service is basically, the job of the service to get a request from the end user, and then record the video, store it in, and then as and when users come and ask for it, you want to scale out and showcase the video. Very simple. In that scenario, as you can see, a request coming in can be called as an event. Somebody creating and then that event can trigger a multiple workflows in the backend: record, store, put it in a cache layer. It can do certain things, and people watching it. So if it's a very popular video, there'll be hundreds and millions of requests coming in at the same time. So you process the request. After that video sort of falls out of popularity, it will go into a stage where there is no need to looking at it. So if you think about it, it's we call it as the event-driven model, programming model, where events are used to automatically manage, scale out, scale in, how the program is going to react to it. So that's where customers want to go with it, because it gives you one major advantage is you really don't need to worry about your underlying infrastructure, to the extent where you don't even care how it runs. All you care about your application and your user experience and other things about it. How it's possible? if you think about serverless, there are still servers in the backend. The companies tend to run it, and it doesn't mean there is no servers in the backend. Definitely, the servers in the backend. You as a customer don't need to worry about it. It also brings in a different cost model. So in the traditional IaaS, you cost it by the virtual machines you run, the storage you have, and the disk capacity you have. Networks you might want to use. It's a different story. In the platform as a service world, you still have to worry about certain things like your redundancies and then your storage capacity. But you don't really need to go and configure your storage, stating that I need 50,000 IOPS of this disk and that disk, and I need to update this patch. That's all gone, but there's still that. But on the serverless world, it's a whole new paradigm. So what's happening in that serverless concept is everything goes by events. So you'd be charged for the seconds this particular piece of code is running. You'll be charged the number of times this particular service is requested. In a millions, it will be charged on that. You will be charged based on how much storage you're using. You don't care about storage in this scenario because internally the company, the provider will worry about how big the storage should be because they're going to get a request. They know how much they need. You don't worry about capacity. So if you think about costing model, this is much, and obviously there is no patch, there's no updates, there is no anything. Pretty much you have a code and the code reacts to an event, and the event triggers workflows, and the workflows would trigger storage requests for storage, and then that's it. So this is where pretty much every company is going through.
Krishna, this is Partha. I want to have a clear idea of what would you people do where they are using microservices, containerized microservices, which collaborate together to provide an application, a bunch of functions. How would this sort of get mapped onto a serverless paradigm?
So there's a bunch of activities, right? If you think about containers, if you take about pure containers, okay, even if you're running a Kubernetes container, things like that, it's still hosted on some sort of platform underneath, right? So
correct.
Yeah. So in this case, serverless is it's one level on top of that. So what happens, technically speaking, we internally, the provider will run containers internally, and then these containers exposed to as an API endpoint as serverless. So technically speaking, I got to tell you. So let's say if you're within, let's take an IT environment, okay, in enterprise. So most customers, most IT environments would run multiple, like they will run a Kubernetes platform. They run containers, for example, for finance, they will have, a couple of containers they allocate for them, and the finance guy building the code would get an endpoint. So the basically containers are think about containers are becoming the new platform that will host the serverless components. So if you think about it, there are certain similarities. Okay, the first similarity is they both run an application code. Okay, they are more efficient than a traditional virtual machine. They also abstract the application away from the host environment. They also use some sort of tool to orchestrate. The difference is, first and foremost, is the self-serving ability, right? In a traditional container world, you still need to maintain, you need to set up some sort of a Kubernetes and things like that, irrespective of what it is, right? So you still have to have that bit of overhead on that. And the second one is cost-wise, because these are hosted on, even if you take a container, there is still a cost you have to pay to keep those containers running consistently to give you the service. But on the serverless, the paradigm changes totally different, where you don't even pay for any containers. You worry only about the piece of code that you're writing into it. So basically, you have a bunch of code and then you basically run for it. And other thing, you got to be very, one thing I think I didn't mention is serverless are basically built to run for a very short time, maybe a few hundreds of a second, and shut down. Containers in this scenario can be used to run long-running processes. Now, that's one key takeaway would be containers, if there is a need to run a batch process, if we need to run some sort of a long-running processes, then you would definitely use a container. But this is where it gets interesting, right? Most of the time, I still have my containers for long-running jobs or long-running processes, but I still have my serverless for a short duration ones. So it depends on your environment, depending on your use case, you differentiate for it. But a lot of companies, what they try to do is they started providing internal serverless projects using containers as a backend. Most of the companies do that these days.
Okay, thank you very much.
So thanks for that. So that's a very key question, Partha, because that question is constantly coming up. I think that's good for clarity. And also, I have to tell you one other difference. Okay, key difference. Containers tend to support pretty much any language you want, as long as you have runtime, you can run it. But serverless has got, it will say, Python, Node.js. It's got a approved list of languages that you can use only for that. And also the other point is persistence. In serverless, the persistent layer is not on the particular serverless. So you have additional storage. On the container, you can still persist. So there is a bunch of differences. Depending on use case, I use both. If you think about the enterprise application, I still use PaaS plus containers on certain types of workloads, and also I use serverless on pretty much for event-driven programming model. Thanks for that.
Yeah, the event-driven, the languages that support event-driven paradigm will be the ones that are supported on serverless, I guess.
Yes. Yep.
Okay. Thank you.
Yeah, that's a very good. Yep. And also, there's a whole programming model coming in for event-driven. Hopefully, I will touch base on it. Event-driven, as you might know, there is a whole bunch of new languages which you have built on it. Your traditional, but yeah, that's a very different. Event-driven model languages are widely used within the serverless community. Yes.
Okay. Thanks.
No problems at all. Thanks for the question. Let me jump. So, because this is going to be for more on serverless, I'm going to at least touch base a couple of pre-cloud and post-cloud and all. Let's just bear with me for a few minutes. Before the advent of the cloud, if you have noticed, you have as an enterprise IT as a customer, you have to take quite considerable amount of our responsibilities under your shoulder. So first and foremost is how much service do we buy, what sizing. I don't know. I used to remember that hey, I need to host a dynamic CRM. So usually the discussion doesn't even start with the business requirement. And today, if you want to go with customer relationship management, you might go dynamic CRM online, or you go Salesforce. You don't even care about how much service you need. You go to the business problem to solve. Previously, it used to be like if you run CBIL and all the stuff, you need to define the sizing, your storage. You need to know exact IOPS requirements, how many reports you have to run. It's a whole bunch of things goes into just getting before even deploying anything. You have to start the job 6 months before, and then by the time you need to order this hardware and software, if you don't do it, basically you're pretty screwed, right? And also the backups, right? The whole bunch of things goes into a traditional before the cloud monitoring is a problem statement, huge issue. So once you have that, the next iteration came in is, so after, this is where infrastructure as a service was like a blessing, and a huge blessing for enterprises, where all of a sudden, hey, don't worry about anything. If you want a server, we can deploy it whenever you want it, within a matter of few minutes, and we will throw in automation. We also throw in tools and technologies that will manage your services, keeps you up and running. We don't care about your disk IOPS. I will give you heaps of disks for you. Don't worry if your server crashes. I will also give you a fault domain that will take care of your physical single data center failures. If you want DR, I'll give you 2 data centers to distinctly separate region. If you have low latency, I will give you availability zones. We give you everything that you need to have to get your IaaS running. So and give you full automation, what operating system you need. Oracle, no problems. Linux, pretty much anything you want to run it. So that's it made life easier. But and then next comes the iteration of the platform as well. Still, customers don't like to run it. So even if you think about large companies like large cloud, so-called cloud companies as well, they don't like the concept of running because infrastructure service, because you stick your challenges on the underlying moving pieces like infra, and there is disks, and then there is operating system. Customers don't want to go for it. We went in the IaaS world, which we touched based. And then I think now the iteration I'm seeing now is serverless. As a serverless, you just have to worry about only an application, and how the application can become serverless. As Partha was alluding to this one, there is a bit of a dependency on multiple size areas, multiple scenarios, but serverless cannot be used for every single scenario. But serverless can be used for a number of new scenarios. If you think about today's day and age, most of the application that you tend to react has got some sort of a serverless component behind it. It could be as simple as you submitting a simple, you try and do a simple chat session. You press the button, submit as an example, and that submit button would be most likely hosted as a serverless event of some sort. If you're ordering something, if you're processing something, there'll be serverless component for it. So that's serverless is the new paradigm. Microsoft would call it as Azure Functions. AWS would call it as a Lambda. So that's prevalent more and more, and it's helping customers reduce cost significantly in comparison with this one. But that's if you don't want that, you still have this much more optimized environment of containers hosted on Kubernetes that gives you flexibility of low maintenance and low infrastructure requirement, but still it gives you additional advantage of your choice of language. You are able to run your own code, plus all the fun bits of building and maintaining your own own smaller domains. But serverless and containers are used in combination to get you this one. So let's go into I think this is the definition. Basically, full abstraction of servers. Pretty much there is. This is sometimes when you read it, you tend to wonder where is the servers are stored. Actually, servers are stored by the enterprises. Microsoft still runs a lot of servers in the back end, in the background, to get you the serverless functionality. There's still servers that as a customer, this is from a customer point of view, there is no physical servers at all. You don't have to worry about planning, availability, capabilities, nothing. You don't have to worry about anything. You have a service. The service is going to be hosted on a piece of endpoint, and the endpoint is going to scale on based on events. Second one is instant and event driven, right? So I think we also spoke about touch base. It's the serverless world. Everything is event driven. That's a new paradigm of programming model, which is becoming more and more prevalent. So that you need a event-driven programming model. And the last one is you pay for use. This is a huge advantage, even in the platform as a service world. Even if infrastructure is expensive too, right? You paid for a service running 24/7, or 365 days of the year. You paid for the services because you don't know when somebody is going to host a file. You don't know somebody that was going to host you a picture. You just don't know, right? On the serverless world, you worry only about if somebody is using a service for a couple of milliseconds, you only get charged for it. So from a customer point of view, this is much more cost optimized model. And traditionally, customers used to have OpEx, operational expenses, but this becomes totally some customers used to have CapEx, they buy capital. This cloud serverless become 100% OpEx, but it creates a bit of a challenges for a number of older industries, but that's how things are going to go on. So yeah. So basically there are three key benefits. One is it solves multitude of business problems. So see, if you think about it, technology has always been one of the fundamental fact why customers use technology is to solve a business problem, right? So technology for the technology's sake has never been successful. So it has to solve some sort of issue or something, right? So it gives you ability to focus only on one thing, which is solving a business issue, which is serverless gives you that, and if it's highly efficient, right? So you basically, there's no fixed cost, there's no infrastructure cost, there is no people. When you say people, it's not the developer, it's basically somebody managing it, fixing it, patching it, downtime, the whole lot of things is not there. And also it's flexible, right? You can start. It's easier to build something. Hey, I need to build a simple function that is going to do 1, 2, 3, and 4. Okay, let's go with that. So, and it's if you're building a huge data warehouse application, if you ask about serverless, I would say no. But if you're building a front-end customer-facing application, which is interacting with the customers, yes, that is there. So we have to put it, when you say flexibility, you have to put that in the right context and then think about it. And it's a natural fit for microservices. So, for example, most customers, what they do is they used to run very old processes, which they want to move into the cloud world, and they start with a simple function to do some basic functionality. I call it as, let's say you have a huge mainframe system, right? And most customers don't want to change the whole thing. They'll go with one functionality. Hey, this functionality of getting the file from this third-party vendor to my backend data warehouse. I don't want to run a non-stop 24/7 process in my mainframe. What I'll do is I will give you API endpoint from mainframe service. I'll create a function that will go and talk with the third-party vendor, get the files every night, and then dump that into my destination. And it will reduce my overhead on my mainframe. It will reduce the number of MIPS I'm using, right? So things like that are getting more and more prevalent. But I think there are additional benefits. I think these are three key benefits that we want to bring in. So if you think about ecosystem, right? So any type of functionality that we provide should have a supporting ecosystem to go with it. If you think about from Microsoft standpoint point of view, the Azure ecosystem provides all the necessary ingredients that get you your solutions up and running. Let's look at the support. The first and foremost is your ability to have a development environment. Having a Visual Studio Code or Visual Studio or any traditional IDE environment is extremely important. It's available to you. Integrated DevOps, what we mean by that is the functions you're developing should be able to have integrate with the existing solutions, with the existing DevOps pipeline, and all the other technical details that you need to integrate your functions into your ecosystem is very important. And development, right? So one of the things always comes up, hey, I'm building my function. Should I need to have my cloud or Azure 24/7? You don't need to do it. What we do is we create local emulators which should reside in your developer laptop that will give the experience of a full-fledged interface in the cloud, as well as you're able to build anything in your local laptop experience. So that's we call as a local emulators are being built using a Visual Studio Code or even a Visual Studio. It gives you a developer experience. The last one is monitoring. Obviously, monitoring is key, especially on the serverless. Sorry, the bigger challenge is these components are very, very small. So what happens is we do a lot of out-of-band monitoring, which means the monitoring would not be coming in the direct path of execution, but it will basically capture the logs and using mirroring pattern, which means as and when changes happen, the functions, the serverless they could execute, there would be a mirror. Those would be mirrored into a secondary path, so that from a performance perspective, the serverless is not impacted, but it still has the full logging capabilities. So if you think about the right-hand side, the platform, there are three key platform layers on it. One is the event grid. So event grid, it's a huge paradigm shift in terms of how components are being built. I'll touch base on what it is. And we also talk about functions, and the last one is logic apps. If you think about these three key things, right? If you think about event grids, so basically as a name indicates, it's basically it's a grid and that is composed of events from different types of services. Okay, if we take Azure, there is storage, there is network, there is virtual machine, there's a multitude of different services, right? And each service will emit events. For example, if you have a storage account, if you store something, it's going to say file stored OK 200, and you can capture that event to trigger workflows, things like that. For virtual machine, if somebody logs in, it will send an event, hey, logged in at this time for this one, logged out at this time at this time. So it gives you events. Every object gives an event of some sort, and these events are captured and put, and then these events are dumped into a queue-like mechanism. So where you can actually go and interact with that queue to create additional workflows on it. The second is functions. Okay, I capture the event. What should I do next? That's where the functions come to play, where it gives you a place where you can put your code, and then based on that event, you can react to that event. For example, whenever somebody on the use case where I told about mainframe, as and when a file is stored in the blob storage, I want to trigger 2 job processes that will go and pick up the file and process it. That's you need a programming model to do that. That's where the functions come into play. The last one is logic apps. Think about logic apps. It's your workflow engine. Okay. Let's take the old example, previous example, where if a file comes in from a third party, you capture that event and put that into, based on the event, dump that files into a blob storage. From the blob storage, you're writing functions that will operate on the blob storage. The next one is, okay, these blobs, these output data has to trigger my payment gateway that will send checks or whatever it is to the supplier that is gave me the file. Very simple workflow, right? That's where the logic apps comes into play, where you're able to build workflows. If you think about what this could be meaning, this could be BizTalk services, or the lot of other systems which are basically you have multiple K2, you have multiple workflow engines. Similar to that, logic apps is one of those workflow engine. The advantage of logic app is basically it comes with pre-built connections with hundreds of solutions like Salesforce, like SAP, like Workday. So the pre-built configurations are available. So this, if you think about this spectrum, one is capturing of the event grids, the capturing of events from the resources. The second one is a function, which basically gets you opportunity to code. The third one is you have a workflow, which basically encompasses a trigger maker. So if you think about it, traditionally you can do the same thing on your your older system, like for events you might have, for queue management you have MQ series, you might have an application code which runs nonstop, and you might have a BizTalk engine to integrate everything. So instead of that, everything is this one is a fully serverless event-driven platform. You're going to have a paradigm shift on your way you're going to work with it. And obviously security, compliance, audit, all has to go with it, because since we're giving the coolest of the function, we can't compromise on identity. That's where the identity would come. Azure Active Directory is a huge identity provider. We have login, monitoring, alerting. We also have other aspects of it. So this is a shell in terms of what you can do. The outer shell is all the security, compliance, audit, other things on top of it. At the end of the day, you have a full end-to-end solution, and in this all with all flexibility that you can build. So that's the reason I spent some time on it. So you guys are all aware of what's happening there. So key aspects of it. Again, I go back to the question posed by Partha. One is one functionality I mentioned is a very short-lived. The existence is very few seconds or few milliseconds. It comes in, it comes live, and then does the job and goes away. So this is where it gets very interesting. Okay, when serverless came in, what company, large enterprises, companies like Microsoft, Google, AWS they realized it, but they didn't address that the day one. There's a thing called warm-up period. Okay, So, for example, if event would come in, and if a particular piece of code is not highly active, if it's in a cold state, which means no execution has happened, it's in a very cold state, it will take seconds to reactivate it. So what's happening nowadays are basically there's a whole engineering work goes into warming up of these functions, these serverless functions, actively make it available. So if you go Google, look for a warm up period of Lambda or functions, there's a whole engineering area where it's a lot of work is going in. For example, if like enterprise company like Microsoft or AWS or even Google, imagine if customers are running millions and millions of functions like serverless, right? And not everything can be hot all the time. So how do you predict which of these so-called functions should be highly available, always hot? Which are the functions which is, let's say you're a developer, you're building a code here, right? You put the code in, you put in the background, don't care about it. So, but if you're building an enterprise application, you have to be always be on it. So there's a engineering work and scientific and also predictive AI and modeling are used to keep to know which are will be constantly being used, which can be put in a cold store. So that's just I would say as homework, just look at it. That's a very fascinating area of emerging where how to keep functions hot. What are the technologies that you can use? It's a massive paradigm shift in terms of how engineering is done in terms of when it comes to serverless. I think we spoke about event driven. It's basically one key. So one key takeaway I want to think about today is functions are fully stateless. State is where you get slowness. So once you remove the state, all of a sudden you have massive speed. But if you're wondering where do I keep my state, you keep your state away from the code in a separate in its own space. But without state, the functions can scale out exponentially for huge. That's why when you see if you take so-called viral videos, somebody might be looking at for one time, all of a sudden 100 million people looking at it. The way they're able to scale is they're making as much as components possible fully stateless, and that's where the speed comes in.
Krishna, I had this basic question with respect to stateless, right?
Yes.
At some point of time in your business logic, you need to know the state to do the next step. And in that case, we have to reach out to, let's say, in a microservice architecture, a stateless microservice reaching to the state microservice to get the state to do the next step, right?
Yep.
Would that not add more overhead? I understand from the architecture point of view, keeping the state in one place is from the replication backup, many reasons it makes sense. But what's your practical experience? I mean.
Yeah, it's a good question. I also wanted to ask the same question because you have to when you have stateless actors there, then every time you need to do something, you'll have to retrieve state and then store the state back, the new state back. So yeah, how do you manage that, or how you have a lot of networking and traffic going back and forth?
That's a good question. I will try my best because I'm not an application architect. So if I understand your question, the question is basically how do you spend time to? Can you repeat the question? I just want to get my head around. Can you just go one more time, please?
Okay, I'll go, and then Kader can add whatever he wants. You have a bunch of stateless event-driven code. So every time, there must be some sort of messaging system that actually is looking out for events that trigger one of these stateless actors to be retrieved, loaded, and then the processing to happen, and then the stateless actor dies. But then the new state must be, it's a state engine basically. So it's a sort of a Petri net. So you have to store the new state of the model back somewhere.
Yep, absolutely.
Yeah.
Yes.
So
Yep.
the whatever is happening, the messaging that is going on between these, let's say the core long-standing application and the various actors who are being brought into play and then dying. So that adds a lot of traffic between the core application and the stateless actors. Both in terms of retrieving the app, I mean, standing up the stateless actor, doing the processing, of course, is there always, but then storing the state back.
Fantastic
Right?
question.
Yeah.
Yep.
So these, when you have, let's say, 300 to 3,000 such stateless components working, then how do you manage all this traffic, or what is the underlying networking and processing increases that we need to do, and what is the trade-off?
Okay. So
Kader, you could please add whatever.
No. I think you kind of asked the right question. And if I had to simplify it, see, there are certain business logic that you write does not require state quite often. Okay, so it makes perfect sense to write a microservice for those. Let's think about we getting up and going to office and coming back, same bus, same time, blah blah blah, right? Well, you can do that. But when that happens, if you miss a bus, as an example, that's where the state comes into the picture. So you got to wait for another bus with another time, right? You need to get the state when my next bus is coming and so on. So at that point of time, you have to anyways go and come back. So the Partha's question was more, sorry, Ajit, I think, right? Ajit's question was more like when business logic requires lots of states to be retrieved back and forth, the stateless architecture would it really help? And what is the trade-off? That's what is.
Okay.
Krishna, this is Ajit. Can I add something to that question?
Yes, please.
Okay. So for example, Krishna was mentioning about event grid functions logic apps. If we look at the traditional on-premise enterprise architect model, we used to have something called the enterprise service bus.
Yes.
Yeah, so we call it as ESB. So the way it works is you have a system or an application, you need to communicate with some other system. You send a message or post something to the ESB, and then the ESB will take care of all the failover and the reliability side of it. And then there will be another application sitting which actually subscribe to for this event. And if I understand correct, in cloud also, Azure also, we have a similar thing happening in the backend for the microservices. It actually ties these functions, the workflows, and the event system. Yeah.
So it's a good question. You know what? I'll do my best to answer it because that falls into a different realm. But let me explain to you guys how it's usually done. If not, I'll get somebody else next week or the week. One of the sessions I'll definitely get that.
I can give some input if you don't mind.
Yes, please. Oh, Ahmed is here. Then then I was okay. Go ahead, man.
No.
Ahmed's comment in the there's nothing called a stateless application, only stateless processes. That's a good one.
Yes, so I'm going to present about Kubernetes and microservices soon in a few weeks. And I was going to touch on that, to be honest, because it depends on the definition of what state is, right? So what you and Kader were mentioning, state, that's something I call configuration. I don't call it state. If it's what the application depends on, let's say, Kader, like the schedule of the bus, that's static, right? That's a configuration that the application will always follow, right? So to me, there's always some form of state for an application, whether it's a configuration for that application or certain static things that it relies on, right, for it to run and function based on the business logic, right? But the other things that you're talking that need to be updated, or what Krishna is mentioning, for example, the use cases of function or logic app or any other things, that's when you need some form of DB, right? That's where NoSQL came out, right? That I can build whatever I want as a document to save any form of state, no matter how random it comes out or no matter what new things show up. I'll have a, but still you'll have some schema, of course, but you'll have, you know, the flexibility to cover these special use cases, right? And that's where you need to save it in the back end out of, and not save it in your process, right? Because you cannot have, as Partha mentioned, like 3,000, let's say, different stateless agents running, and all of them keeping state. That's not possible. You need a common location where it stays, right? That's going to be something like Cosmos DB in Azure, right? Or even if it's only something that you need to cache and not save for long, you have a Redis cache that you can use for very quick access, right? There are so many solutions that can help with that. But saying that an application or a microservice is I hear that often, but I really don't believe in it because it causes a lot of confusion. And that's where people really build bad microservices, because they end up treating a microservice that it has to be definitely stateless, and I don't care about the configuration. But in reality, the way it is stateless is only from a process perspective, that when I run my microservice, or I run my nano service, I'd like to call a function as a nano service. If I run that, it doesn't care what my where the state is, right? It knows where anything that needs to be saved somewhere, it knows where it save it in terms of a DB. And like now, it's all the era is all about data collection, right? Everyone is always collecting data, even if they're running a microservice or they're running a function. Even the logs for that, you have to save it somewhere, right? So there is always some form of state. It's impossible to say that it's fully stateless. It's just that the logic of your application that is running, or the process, does not really, the process itself does not rely on that state. That's pretty much it. If you're getting my point, you know. You just need to separate them. Like, that's how Kubernetes come from. You have something called config maps in Kubernetes. That's how you deploy the configuration, and you have secrets. That's how you provide the secrets that the application needs. But the pod itself, or the application, is simply just running the process that relies on that. So in reality, from a logic perspective, it's not stateless, but the pod as a process is stateless. Yes, it can go away and come back and still can find the configuration it needs, if you know what I mean. Hopefully that explains things a bit.
Yeah. So I mean, it goes back to the same thing, right, Ahmed? You're writing a business logic, and you're not storing the state in the process or the microservice. That process is being designed in right. But for the state, you have to go out and come back, right? Whether it is a configuration, whether it is a dynamic changing state.
Not really, Kader. No, the configuration doesn't have to go out, right? If it's static, it lives next to it. Like in Kubernetes, it's in the same system, right? Or in your function, it can be part of your, if it's non-secretive, it's not a secret, it can live part of your source control. This is the configuration I'm going to use that my application needs.
All right, so I agree. Like configuration, let the configuration be in the same microservice, right? Or within the same system that you can access. You just don't have to go to database or whatever to access. What I'm also seeing is, at least I'm in the telecom world, right? So what I'm also seeing is that there is an initial configuration, right? That's your first one, which is, there are configurations that are static that would never change, right? But there are configurations that would change in the runtime too. Right. So for that case, we have to deal with it differently. But in general, it does not answer the question. What I had was the going back and forth between stateless to get the states and stuff like that. Based on your experience, what kind of impact it creates to the architecture as a whole? And I know an answer could be a case by case. You can say it. Share your experience. Yeah.
Let me give. Okay, this is a very good. Let me put that context. Okay, so there are solutions like I explain to you. I'm building a solution which is for order processing and order. Okay, an order processing system, and all my so-called state is going to store in a database. So usually, what happens when you're building these sort of solutions? So there will be intermediate layer which will call streaming data sets. Okay. I could use a Kafka streaming bus or things like that. So at any given point in time, I will never update my backend data store. I will update my streaming data sets. In this case, Kafka would be my centralized storage where all the events are going in. I pull the events and process it and put it back. So you never flush anything into the data store until it's fully completed transactions, right? So there's a whole design pattern which is called streaming processing. So where stream processing, where the streaming, in your case, the Kafka would act as an intermediate layer. So you can pull information, push information back, but you're still not going to a data store directly, but you're using by passing through data streams and then pull and push information onto the data stream, and only data is flushed as an end state for it. For example, if you take things like even an order processing unit, that would be special, I would say, queues or channels, whatever that is specialized for, okay, order submission. It will go and pick up the order from that particular information, put it back. So I can share the like a picture. That's the closest picture I could find. So all this, when I say the stateless so-called ones, they'll be interacting with some sort of a queue engine or some sort of an engine which would act as an intermediate buffer between your full data store, and then that buffer is used for processing all the data points at that given point in time. But still, it's much more faster, because as you can see, when you have Kafka, there is a special way of accessing them using keys and things like that. It's highly efficient, and Kafka doesn't care. I think it looks like a byte versus individual data points. So it doesn't really care about integrated things like that. You can pull and push back in. So if we maybe next time we will spend specifically on that when Ahmed is talking about Kubernetes. There's a whole topic on its own. There are other.
Understood. But it's clear. I understood that there are multiple ways to solve the problem, right, Krishna? What I was asking was mainly, based on your experience, but I think you kind of shared it. But we'll talk more on the Kubernetes. I'll let you to complete your flow. Sorry. Yeah.
Yes. No, it's fine, because we dump the store into a data store of Kafka, and then the Kafka would be the intermediate layer, and then the last end state would be on a data store, like a database. So
yeah, that makes sense. But yeah, you need some sort of intermediate storage, like either Redis or something.
Yes. Key value pair of some sort, where you go to that and pull the information, push it back. I don't remember the exact architecture term for it. So
it's called pub sub.
Yes,
publisher and subscriber. Yeah.
It comes back to the same enterprise service bus type of thing.
Yeah, exactly. That's as you mentioned. So that's the event grid or event hub, which can run Kafka as well in Azure. So
much clearer now. I've got a much better understanding of what the stateless is about and where it can be used, where it cannot be used.
Yeah. Hey, I just wanted to kind of take this opportunity, guys. You heard Ahmed, and I kind of told you last time as well that Ahmed is going to take the Kubernetes session starting from August 15th. That's 2 weeks from now, right? As you can see, he's already an expert, created an impact today, and we're going to hear a lot of good things from him. Make sure if you have not registered it, please register it in the Eventbrite for the Kubernetes session.
Yep.
Okay.
I worked with Ahmed for 18 months. So if you take about engineering depth, I think I know he's going to blush. He's already he'll be already pink by now. But from a depth perspective, the conceptual understanding of Kubernetes, the security, the compliance, the audit, and also the implementation aspects of it, he's one of the best engineers I've seen in the recent times. Not only that, he's got a very strong understanding about the security aspects of it. For example, that's it.
Ahmed has already put some kind of a smiling face with a lot of lipstick.
Blushing face.
Yeah.
Yes.
Blushing with lipstick.
Thank you,
So he's exactly saying, "Don't kiss me, Krishna."
Yeah.
And then other thing is, I want to tell you, we worked on especially on the Istio side, which is a very complex piece of software on the ingress control. So he has done a fantastic job. I think I definitely make sure that I'll try and attend this session. Is one of the best sessions you're going to be in. So yeah, I'm happy. It's hard to get him. So, but at least from starting next week, 2 weeks from now, he's going to be presenting it. So make sure you attend the session. So okay.
Yeah, Krishna, there was a lot of questions about what happened. Krishna was supposed to do AI. I just wanted to address it. He'll try to cover some basics next week. But remember, after Ahmed's session, we're going to have an AI dedicated session using Python from Shad, right? So you'll learn more after Ahmed's session.
So next week, what I do is, I'll extend it by 30 minutes more. So I cover it because in my scheduling, a lot of things overlaid on it. I was focusing on this session, and then I totally, didn't. Maybe I'm doing too many sessions. I was doing another session with another team. On that I finished it, so a lot of confusion. But anyways, I won't give us excuse. Definitely next week I'm going to touch base and finish it. So let me come back to. I think the benefits of the serverless. I think I'm going to skip some of the slides. I really want to touch base on. I really going to get the decks for you guys to review. I just want to jump into where it is. There's a whole bunch of use cases where it can use. The one I want to show you guys.
Yeah, we'll be putting this presentation in the Microsoft Teams, right? So you guys can just look it up. That should not be an issue. Yeah.
Yep. So,
but in future session, Krishna, we will get you to teach this in detail, right? Because it's a cloud fundamental session. I'm letting you go with a high-level explanation. But in the subsequent next year, we will get into the depth of these.
Absolutely, as we will do that. So I just want to touch base on only one thing. Okay, so this is a slide deck I want to quickly touch base. So you've seen this one initially, right? So if you think about the ecosystem, if you think about the top layer, Microsoft Flow, this is where we call them as a democratization of code, where if you think about Power Apps, if you haven't done it, I definitely recommend you guys go and look into it. Power Automate, and obviously the entire Power Platform goes into this whole new paradigm called low code, no code. It's a very catchy keyword, low code, no code. Actually, there is no code. You don't have to. So where it is going towards is you don't have to write code to build any application that is going to be useful for anybody, enterprises or individual. That's what it's a. I think this whole momentum started because everybody wants to build some sort of application use case or something, but getting into coding is a huge barrier. So the whole notion of the Power Platform, I definitely recommend you guys to go and look into it, where you get a platform called Power Platform. You drag and drop components into it. If you want to build a chat for your customer, it's as simple as bringing in components using an UI interface. And then you build the entire deployment and then dump that code into a solution stack. That's it. Kadir, this is if you think about next year, this is one of the areas we should definitely touch base. This concept no code, no code. That's the think about that's becoming your front end layer for enterprises to move on. So which means you could be somebody sitting in your accounting team, but they can still write applications that can actually provide a lot of value because of the fact a lot of the backend services are becoming APIs. You pull the API into the low code, no code environment, and then you capture that details. You have the connection points, you drag and drop, and you're good to go. So that's the next years. I definitely want to do one of the sessions. Underneath that, we talk about logic apps, and obviously API management is a huge. Basically, the entire able to expose services to external, internal participants using APIs. The API management plays a major role, and obviously service bus. Service bus is basically your traditional enterprise service bus, but it's cloudified. And the last one is Event Grid. And the underlying layer of Microsoft, a lot of these services had the origins on BizTalk server. If you're looking at BizTalk, even I don't know, hundreds and hundreds, thousands of maybe millions of enterprises are still using BizTalk as the core engine for transformation and for a lot of multiple different things, but still. Iterative the BizTalk has morphed itself into something more cloud, but it's still there. The underlying layer is all Azure. So this is the entire, I would say, ecosystem of functions with event grids, with the traditional enterprise layer, logic apps. It all gives you a single unified platform for you guys build and grow. On top of that, best advantage with Azure is the IDE layer of it. So this is a one single slide. I just want to give a big picture of it, and there is a whole bunch of things I want to touch base quickly on this whole notion of logic app. Why do you need logic app? Why can't you use BizTalk or traditional ESB? So yes, you can do all the things that you can do on it. If you have a BizTalk or an enterprise service bus, you know, I don't know, I2, I know they had a whole company which I totally, the name is not coming to my, I'm not able to get into the brain right now. A lot of services, but where where the value of logic app comes in, pre-built connectivity, pre-built integration, right? If you are a customer that are going to build these services by hand, you need to go, for example, if you want to connect with Salesforce, right? You need to go understand which APIs and how to test it and make it work. The whole security and identity, the whole lot goes into it. But if you go to Logic App, you drag, hey, I want to connect with my service with Salesforce. I want to connect my service with Twilio. I want to connect my service with PagerDuty. Boom, no problems at all. API available, drag and drop, and then you can, that's it. You get deployed out of the box, no issues at all. And the best thing is you get charged by only for the service you use. Obviously, which also we have traditional enterprise service bus, you pay for the entire infrastructure. All of a sudden, you start using only for the service here. And we touched base on event grid. So 3 key attributes. It's basically think about event routing. The second one is it's near real time, which means there'll be a couple of milliseconds of latency, but it's still close enough for most of the use cases you deal with. And it covers with all major Azure services like storage, networks, virtual machines, functions and apps and whole bunch of stuff, because we're wondering what it is, because these are the resources or the ways that you interact with your applications, and you capture all the events and then you do a logic on it. That's a huge advantage. I told you a simple example of the blob storage being used to store some files from your third-party system and used for processing. It goes on to showcase what value it provides. And then benefits, we talk about benefits, and I think main thing is the cost, right? If you think about a couple of key takeaways is stateless from a function perspective. The second one is you pay only for what you use to the extent of the second. I don't know what the next paradigm is going to be. Somehow some people have to get paid. If it's going to be like a event based, I don't know what next paradigm is going to be. But yeah, the bottom line is the cost reduces significantly. And just there's a sample example of, if you see the left-hand side, so these are the different types of events, IoT hub, blob storage, container registry, and all of the events can be manipulated using one of those other, the right-hand side, the functions, the logic apps can be used to interact with them. What else I have? And also manageability of events also plays a major role, right? So one thing is you don't want to have events scattered across multiple different storage solutions. You can capture them into a single place, and then that's where something like event hubs comes into play. That's where it's, things like Kafka comes into play, where you're managing those events in a structured form. So yeah, again, the couple of things. The one key thing I want to mention is the protocol. It's a HTTP protocol, which means you can use it from anywhere without have to worry about. See, if you think about one of the paradigm shift that has happened recently is the ability to use standardized on protocols. Okay, if you take telco, which Kadir knows quite well, I started telco only in about say 2 years ago. When you think about the backend, each vendor, Nokia, Cisco, Huawei, everybody has got their own protocol mechanism, own way of doing things. But off late, all I'm seeing is every vendor gives you HTTPS, HTTP. So and just by the fact of that particular protocol transformation, you have ability to interact with any service you want on demand. On basically when you want to do it. So the whole notion of, even if you take a lot of the Azure services, there's always a way of connecting with them using HTTP, HTTPS type protocols. It removes the traditional way of, you need to know a certain type of, you need to understand a specific vendor's way of interacting with it, or different types of protocol these guys come up with something. They invent a new protocol, which means I learn for it. So which means one of the other aspects I wanted you guys take off from a whole this discussion is the standardization of the protocol, which is a huge win in my view. And the last one is highly available. You see, getting if you think about it, if you are in this industry, achieving 4 nines on any application or any solution it's a huge task. Not because of the technical complexity, but the investment you have to make to get 4 nines is mind-blowingly complex. But because these services are built and managed by Microsoft at scale, you get the service availability. And imagine the events of it can handle in a given second. And also there's also getting more and more better on the reliability metrics, where we can give you up to 24 hours retry of, one of the things you also learn from the programming model is, I give you a simple example. It's called erasure coding, ERAUSRE coding. So for example, when traditionally when a database is going down, if a database is written back saying that service not available, you basically throw an error message, database not available. So in the new paradigm, because these services are highly available, when a database is not available, it's not responding, not available, you retry the same service after 5 minutes or 10 minutes or whatever the duration you have, the service will be back. That's the expectation, right? So this whole retry mechanism has to be built in on all these functionality, so that you deal with failures more graciously versus abruptly finishing the entire processing of it. So that's what I think Parth also mentioned about, hey, there's a new paradigm in terms of event-driven programming model. One of the event-driven programming model aspects is the ability to retry at regular intervals and making sure, when things break, you don't exit out. You basically retry and then you exit out gracefully after a certain number of attempts as well. So I think that brings me to the last slide here. That's it. I think that's all. I'm over by 9 minutes. Hopefully, after the session, you should be able to appreciate different, I would say, serverless and the functions and the containers and what are the key aspects of it. We touched base on the protocol layer on it. We touched base on stateful and stateless services and how to keep your state on an event on some event engine. So yeah, so next week would be the final week. I will try and maybe we'll take 30 minutes more and cover all the pending things, starting with the AI and ML, and also touch base on the security aspects of it, and also I'll do the finishing one. This is one of the sessions where it's all theoretical, understanding the basic concepts. You can come back to the session anytime you want, but moving forward, my other courses are going to be more hands-on. So yeah, Kader, and over to you. Thanks, Ahmed. I didn't expect, and by the way, thanks for jumping in, Kader. Really appreciate it. Yeah,
star of the show, Ahmed. Already you kind of blessed him many times today. Yep. Hey, thanks, Krishna, and I'm looking forward to your last session for this particular topic, right? Of course. After AI, you're going to come back with new topics and stuff like that. It's already there in the Eventbrite, guys. Most of the topics that we are going to cover until end of this year, most probably first week of December, is already in the Eventbrite. And for the next year, we will start the session something like third week of January onwards. We'll continue this IA track as well as the TA track for next year. And there's many topics we are planning to cover, and most of the topics are going to be hands-on. So be prepared after today's session, after the Cloud Fundamental sessions, starting from Ahmed's sessions. Be prepared that you have a computer in front of you, not phones, and you have the tools that is required for you to follow what Ahmed and the future session is going to be. It's all going to be code along and learning sessions, detailed hands-on learning sessions. I just want to make sure you understand that.
And I have a hackathon called Cloud Architecture Framework Hackathon. Because we learn concept, I really want to come up with a use case, a real use case, and then try and deploy that, solve that business use case with a cloud solution framework. and then come up with a simple workable solution. It's a hello world application, but from concepts to a business problem to a solution state and implementation. That's going to be it's going to be an interesting session that you'll all enjoy it. So yeah, thanks guys. So really appreciate it. Have a nice long weekend. As always, Kadir and team and all the questions, thank you guys very much. You will get the slides shortly. As always, share your feedback, anything. So yeah, thanks Ahmed Arb for getting an entry. Yeah, thank you guys.
Thank you, guys. Take care. Have a great long weekend. Ahmed, I will call you. I have something to talk to you in short. Yeah,
Okay.
thanks.
Thanks, Krishna.
Thank you guys. Thank you guys. Thanks, Partha. Thanks. Bye-bye.